Hi, this is lesson 14 in the use of JASP and understanding statistics. And today we're going to do a recap on the simple independent groups t-test, one of the most fundamental tests in statistics. To our three bars, opening up a file that we've been working on. If you're joining us without having done the previous files, you'll just have to watch along. But we're going to go to Bank Revised '05, which we've been working on for the last several lessons. We're going to open up that file and we're going to do a very simple t-test. We're going to look to see whether or not the beginning salaries of a set of employees at a bank differ as a function as to whether or not they are male or female. Lots of complexities in answering whether or not there's actually discrimination going on. We're not going to address that. It's purely correlational, but let's take a look. So t-test, independent samples. I'm going to use gender as my grouping variable, and I'm going to go to salary beginning as my dependent variable. Already I can see that there appears to be a significant difference. I'm going to add onto this a location parameter, a confidence interval, an effect size, and basic descriptives. Okay, let's recap what we have. We have males making an average of $24,000, females making an average of around $16,000. That's a sizable difference, and in fact, the size of that sizable difference is $8,558. Males are making $8,558 more than females. We have a confidence interval for estimating that difference, which implies that it's likely that the true difference is somewhere between 7,000 to 10,000. The effect size estimate is 1. 0.8 and above is a strong effect, so this appears to be a strong effect. Okay, now we're going to do some rain cloud plots to see those differences. And we can see that that distribution does not look normal. This is the male salaries are very spread out compared to the female salaries. Can do bar plots. And here we see our estimate of the male salaries is around $25,000, somewhere in that standard error, and the females is somewhere in the $15,000 range. Okay, so that gives us some visuals for what we're finding. Now, what these last various lectures have been about is assumptions. So in order for us to be making a valid inference, we're supposed to meet the normality assumption and the equality of variance assumption. So I'm going to click on these 3 points over here to evaluate the assumptions. With respect to normality, the Wilk-Shapiro test is saying that we don't have a normal distribution. But if you've been following along on the various videos that we've been doing, this is an overpowered test. It's better to look at how the data points indicating how the distribution lines up to what is theoretically expected, how well that's doing, and it's not doing very well. We want to be closer aligned to the theoretical quantiles that represent a normal distribution. So it does look like it's bad. In terms of the equality of variance test, we can see that the variances are not equal. And again, you can see that over here. There's a lot more variability here for the males than there is for the females. You can see that in terms of the standard deviations. Males have a standard deviation of around $11,000. For females, it's around $3,500. So much larger variance for the males and for the females, and those should be equal. So what are our options for making sure that we're making a valid inference? Well, when we're violating the equality of variance test, you can do a Welch correction. So here's the Welch correction, and the Welch correction is coming out showing pretty precisely the same thing. So it doesn't seem that the violation of the homogeneity of variance assumption is having a detrimental impact on the inference that we're making. What about violating the normality assumption? Well, you can do a non-parametric test that doesn't assume that the normality assumption is being met because it works simply off of the rankings. And this implies that if you look at the data in a ranked form, that there's about a $5,400 difference. So it does change how big the effect is, but it's still showing that there's a significant difference. Now you could stop here and you could basically report the Mann Whitney and say you're done, and that there does appear to be a difference, significant difference between the groups. But you might want to approach things another way. And what we've been learning is that you can approach these violations of assumptions by looking for a good transformation of the data to make it more normal. And the distribution that we found in the previous videos, we won't rehash what we found in the previous videos, but we found that the reciprocal worked the best. So I'm going to put in the reciprocal here as a dependent variable. You notice that when we look at the reciprocal, that it's actually coming up with an even stronger effect. Hence, the original would be a more conservative estimate and is more easily interpretable. So I would not be inclined to report the reciprocal, but I do feel good that it's showing that I have a truly significant difference. Notice that the Welch version of that is showing it to be significant, but we don't need the Welch on this because when we look at our reciprocal, notice that it's non-significant here. This is a test of the equality of variances, and when we do a reciprocal transformation, which you might have thought was just to make the data more normal, and it was to make the data more normal, but typically when you solve the problem of the data being non-normal, you also end up solving the problem of equality of variances. And that is exactly what's happened. In fact, we did a better job of solving the equality of variance problem than we did the others. You can tell that when we go and look at our descriptive stats. Notice that our standard deviations of the two groups are very similar. Notice that, these distributions, the males in green, the females in orange, the overlapping distribution in kind of shaded salmon, that those two distributions look like they're spread out about equally. You can also see that with the box and whiskers plots. It looks like there's a similar spread. You can see that in terms of just the distribution of the data points. They look like they're equally spread. From an interpretation point, though, you're seeing the same pattern here. Males make more than females, but the reciprocal really gives you a problematic interpretation. Notice in terms of the normality assumption, we're still showing a violation of the normality assumption, but again, this is overpowered. And these data points are now lining up, residuals are now lining up on the normal distribution line in a fairly nice fashion. So it indicates that we no longer really need to worry about the normality assumption. In short, you have two choices. You can go in terms of solving both problems with the Mann Whitney U, or you can go with doing the reciprocal. In all of these cases, you're finding the same thing. So in the end, what I would report is the simple student t-test, noting that there's an $8,558 difference between the two, having covered my bases, knowing that I get a significant result in any of those cases. And if reviewers come back and ask me whether or not my results could have been impacted by a violation of the assumptions, I can report, no, I get the same thing no matter how I analyze that data. If you do get differences in the findings, then you should go with, say, the Mann Whitney U or the reciprocal if those differences are giving you something that is non-significant, then that's a problem. And then I think you really should go more conservatively with the test that gives you a correction. That's that for the t-test. Hope you learned something, and we'll be on to continuing our journey in future videos. Bye.